Hello students, welcome in your chapter 7 integrations part 2. Yes students, I hope you reach daily formula at least 5 times. So I request to you, just before starting this part, you write down formula one time at least. Yes. Now our numericals continue 7.1, question number 13, 14, and after that I explain 15. Students, here denominator, anyhow you can remove. Here no important what part given in numerator, but denominator anyhow you can try to remove. So x minus 1 or denominator given. So I just making factor in numerator x minus 1. Here common taking x square. Here also one common and x minus 1. Sometimes students, if the factor not available in numerator x minus 1, then what to do? Do the long division method. Yes. Now here very easy. X minus 1, x square plus 1 and this cancel. So you can try x square dx and here 1 dx. Your answer is x cubed by 3x plus c. This integration of I very easy and successfully done. Now continue 40. Students, here 40 the product given. It means I just multiply inside and remove the product. It means first data is x raised to half. Second, x raised to 1 with the half. So my first value is x raised to half dx. Another, yes, correct thinking, 3 by 2. Now x raised to n plus 1 by n plus 1. So my first answer is half plus 1 and half plus 1. Similarly here, 3 by 2 plus 1, 3 by 2 plus 1. So indirectly your data is 2/3 x raised to 3 by 2. Here 5 by 2 upon what? 5 by 2 means here 2 by 5 and plus c is as it is. So finally students, I just write down here properly, here 2 by 5 and x raised to here 5 by 2. Now 15. 15 also gives root x means x raised to half power, and all values that I multiply them 1 by 1 and try to remove our product value. So my first value is 3 x raised to half with the square power. Continue 2 1 with the half power and here 3 x raised to half power and dx students as it is. I just multiply 2 plus half, 3 1 plus half and 3x raised to half. So 3 here 5 by 2. 2 and a half become 5 by 2. Same. Here x raised to 3 by 2. And same x raised to half dx. Now try to answer. What is answer? Half plus 1 by half plus 1. It means 3x raised to 5 by 2 plus 1. Here also same. Continue to 3 by 2 plus 1 and same as students, here also half and half plus 1. I operate here first formula x raised to n wise n plus 1 denominator n plus 1. So my answer is 3 7 by 2 7 by 2. Same here 5 by 2 5 by 2 and lastly x raised to 3 by 2 upon 3 by 2 plus c. Students, this 3 gone. Here 6 by 7 x raised to 7 by 2. Same as 4 by 5 x raised to 5 by 2. And here 2 with the x raised to 3 by 2. And that students here our these questions is 15 and 14. These are equal level question but 2 marks. Here easily done. Now continue students, question number 16. Same pattern question. Here 2x, 3 cos x and e raised to x. All are separation given. So I just write down 2x one side, 3 cos x one side and e raised to x is variable students one side. So my answer is easily here power given. It means 1 plus 1 by 1 plus 1. Cos integration, yes, correct thinking. And e raised to x, I know that answer is 2 and this 2 cancel. Only x raised to 2. Here 3 sin x plus e raised to x and plus c. That's your happily first question done. Here also same all products are different given. So one of the 2 x square dx students. And after that I just write down minus 3 outside sin x dx and 5 here x raised to half dx and formula operate. So x square is a, you know that 3 by 3. Yes, plus 1 by plus 1. This 2 plus 1 by 2 plus 1. Sine integration minus cos x. Correct, no? And last answer 5 half plus 1 with the half plus 1 plus c. It is first formula operate. So here students my answer to third x raised to 3 plus 3 cos x. And here 5 x raised to half plus 1 means 3 by 2. 3 by 2. And this 5 are same written. So my answer is to third x raised to 3. 3 cos x and here change by 3 and x raised to 3 by 2 plus c. Yes students. Sometimes in exam asking here a, b and c and what is the value for a plus b plus c you can derive. Sometimes asking in the MCQ level maybe this question asking in either 2 marks question and after that you simplify. Very easy. Same here students. This happens one thing like anyhow, first of all you think in your mind multiplication and division forming, you can just remove first. It means you converting into addition and subtractions. So my first data is x square x plus sec x into tan x. Now both subtraction 1 by 1. So my first value is x square x dx and another sec x into tan x dx. And both formula we know here. It is a, yes, which derivative? Tan x. And here, yes, it is a sec x. Already we written formula 1 to 20 formula. Yes, sorry, 1 to 18 formula. Students, here 18 questions, very easily and happily here done. Yes, students, now continue our next questions. 19. It's also trigonometry given sec square x by cos x square x. But students, I remove denominator. You told already. Yes. So, what of this x square x? I write down 1 by cos square. Here 1 by sin square. And both terms you can just now I arrange numerator, denominator, numerator. It's what? It's nothing. Sin square x by cos square x. And that is known here, which is tan square x. And tan square x of the converting of the formula. Possible? Yes. 1 plus tan square theta is equal to what? Sec square theta. So can we write down here sec square x minus 1? Because we know that tan square having no integration. But that are integration known. Sec square x. And here 1 dx. So this answer is the integration of sec square x dx and 1 dx. That is known tan x. And it is a x plus c. But main important students, you don't write down tan square x direct integrations. There is no formula. So I convert it into 1 plus tan square is sec square. So tan square is what? Sec square x minus 1. And sec square integration known. It is a tan because actually tan is tan. Now here also you can derive both of the separations. Denominator is so 2 by cos square x. Next 3 by cos square x into sin x. So can we write down this cos square x is a single cos and cos? Actually, it is indirectly cos square x, but it is tan. It is sec. So my data is 2 sec square x minus 3. Here sec x into In short, my data is ready. This integration I know. This also known. So 2 10x. And here 3 seconds plus c. And that's your easily. And very easily answer because tan derivative is x. And here sec derivative is x. Indirectly antiderivative is that 10 and here seconds. Same. Here students, remove the denominator every time I tell you that x raised to half. Can I write down? Here power it minus half. Here simple. Now both separated. So integration x raised to half dx. And here minus half dx. Now only one formula. N plus 1 by n plus 1. So x raised to half plus 1 upon half plus 1. Same is here also. Only first formula I operate x raised to n raised n plus 1 upon n plus 1. Now my answer is 3 by 2 upon 3 by 2. And same as here students, I write down half with half. Now rearrange. So 2 by 3 x raised to 3 by 2. Here 2x raised to half plus c. And that's your easy to easy answer. Here happily students done. Now I am going to 22. Yes, 22 is a IMP question. Asking in exam that type questions. Students, in this textbook, two numericals given. One of the here, one of the example. So these are given. If d dx of fx 4x cube minus 3 by x cube. It means this, that, it is that. So I taking antiderivative. So students, here taking integration of both sides with respect to x. Integration of both sides with respect to x. Actually, this derivative or integration side by side cancel. Only you have to fx. And that side 4 x raised to 4 by 4. And here 3. Otherwise, students, I just write down one more time steps. X raised to 3 dx. Don't take direct. Power it meaning first x raised to 4 upside. Now answer. Here 3 plus 1 by 3 plus 1. Same. Plus 1 by plus 1. First property operate. X raised to n rise. X raised to n plus 1 upon n plus 1. Now answer. So this answer is fx. 4 and 4 cancel. X raised to 4. Here students, plus 3 and x raised to cube is downside. Plus 6. Actually here minus 3. Converting into minus 3 plus. And this 3 and this 3 cancel students. Sorry, my mistakes. Here minus 3 and here minus 3. Cutting that. And x raised to minus 6 denominator write down. This fx now I utilize 2 in that such that fx. F2 equals 2 given and now operate with the parts of our F2. And after that my answers. It's very easy for me. But here to only fx derivation only. Students. Only fx derivation. So what you getting fx? X raised to 4 1 by x cube plus c. But f2 is 0 already given in question. So here operate f2 2 raised to 4 2 raised to 3 plus c. And f2 is what? 0. That the given. So here 2 raised to 4 16. And here 1 by 8. Yes. So c is equal to what? 16 plus 1 by minus coming. Now 16 8 are. Yes, 16 8 are. And plus 1 taking that. 8 6 are 48. 4 carry 8 1 is 8 plus 4. 128 plus 1. So c become minus 129. This fx again taking that. So required fx. Your question asking x raised to 4 plus 1 by x cube plus c is minus 129 by 8. And that's the MCQ option given. This also MCQ option given. You check in the MCQ answer and get the answer. Now students, after ending our happiness first exercise 7.1, I start examples. In example 1, find antiderivative using method of inspections. It means utilize derivative method. But I explain both way, shortcut and method wise. Students, the first one, cos have check. Coefficient is 2. So my answer is 1 by 2 sin 2x plus c. This property I explained. Already known you. F of ax plus b. What is the coefficients? 1 by f of x plus b plus c. That's our answer. So, in another method, I explain about the method of inspections. It means nothing, students. d dx of sin 2x we can show 2 cos 2x. So, d dx of half sin 2x is what? Cos 2x. It means this integration is that already written. So integration of cos 2x dx is an antiderivative, is a half sin 2x plus c. And that's the nature answers. Same here. Check students, I direct going to answer. It is x cubed by 3 and here 4 by 4. 4 gone, 3 gone. Your answer is x cube plus x raised to 4 plus c. Now I start another method by the method of inspections. It's very simple. Yes, apply the d dx of x cube plus x raised to 4. Derivative 3x square 4x cube. It means this derivative is your question. So integration of that 3x square 4x cube dx is over that x raised to 3 x raised to 4 plus c. Yes, and that's easily and happily. Students, your answer is over here. Now, third already you know. What is shortcut answer? 1 upon x. Which derivative? Yes, log modulus x plus c. Either I go to second method. It is same d dx of log modulus x, which is 1 by x, but for always x greater than 0. Yes, not write down the less than 0. I also check in the textbook. X is given that x not equal to 0, but you consider it is a positive here. So antiderivative of 1 upon x dx is a log modulus x plus. So this derivative is a 1 upon x. So 1 upon x is integration is what? Log x base c. Yes students, here of course little examples over here. Now slowly students, I going ahead. Example 2. Now direct method. X cube minus 1 by x square dx. But I told you anyhow remove the denominator. It means students, here I am making the separations. So my first separations, x cube by x square and 1 by x square. Very easy. It is x and here x raised to minus 2. So my answer is x raised to 1 dx. Another x raised to minus 2 dx. So my answer is 1 plus 1 by 1 plus 1. Same here students. And easily you can create your answer. So this answer is 2 by 2 and here see it will be 2 by 2 here minus minus plus 1 by x plus c, and that's your answer students. Here minus x power d, I am taking 1 upon x, and this minus 1 and this minus, it is plus 1, and this happily students here done. Now here same x raised to 2 third and 1 dx. Same application, 2 third plus 1, 2 third plus 1 and plus c. It is a what? 2 third plus 1? It is a 2 plus 3. 5. It is 3 by 5. X raised to here 5 by 3. Yes. Next here x plus c, and that's your answer students. 5 is denominator and 3 LCM check upside. Next. Same is students, this answer is x raised to 3 by 2. Make the constant outside first of all. 1 upon x dx as it is. So again same principle, x is to 3 by 2 plus 1 plus 1 e raised to no new e raised to, and that is log of modulus x. Easy. So you create your answer 2 by 5, 2 plus 3, 5, 2 upsides, and here x raised to 5 by 2 plus 2 e raised to x and log of modulus x base e plus c is same as, and that's to create very simple understanding of our example number 2 here, students. Now students, continue our new example 3. Here also 3 numericals, one by one I explain you. Sin x plus cos x. Students, you can just write down sin x separate and cos x separate. Now integration of sin minus cos x and cos integration only sin x plus c as it is. Yes students, our happily first question is done. Now second, I just multiply here internally one by one. So that will be cos x into cos x square x, and second cos x into cos as it is. Now you can try both separate. One of the cos x square x dx and another cos x into cot x dx. And this integration you know. Which derivative is this? Minus cot x. And this also which derivative? Minus cos x. That type numerical already I explained you in the exercise 7.1. Now third. Denominator given. Anyhow, denominator separate. So I just write down 1 by cos square x. And students, sin by cos square x. And take out to both separations. Here no doubt it is x square x. But can we write down here one of the cos and cos here into 1? Actually this is a tan x. And that what? Sec x. So my data is the integration of sec square x. Here tan x into sec x dx. So finally you can take both separation wise answer. So integration of sec square x dx minus tan x into sec x dx. Now answer very easily. That will be tan x because sec square x is the derivative of tan x, and here students sec x plus c, and that's your answer students here happily. Our example number 3 very easy done. Now students, time coming to IMP questions. It's the same as already I explained in the most IMP numericals related. Our exercise 7.1 already I explained you, and this example number 4. Find the antiderivative of f of the function f defined. Fx given 4x cubed minus 6. So you are taking here both sides integrations and trying to integrations find out to your fx dx. Yes. This is also 4x cubed minus 6x dx. So does this is a derivative, antiderivative of fx already given that it is capital F. So this answer is you write down capital Fx. And here as well as method 6 outside. Why write here x capital X? Read that antiderivative of f is that of small f. It means this integration is that given fx. And that answer is known. It is 4 by 4 6x plus c. So what you value fx? X raised to 4 minus 6x plus c. Now this is the fx ready, but that I give at 0 is equal to 3. So I write down from given. What is that? F capital 0 is equal to 3. It means students, here this 0 will be attached x in place of x. So as x is equal to 0, I just operate in the fx. X raised to 4, 6x plus c. And that will be, students, answer create. We have f0. 0 4 power 6 into 0 plus c, which is 3 only. It means c value is ready that. And this answer will again put it in the fx. So required fx, students, your target is what? Find out, define the fx in the antiderivative fx. So your answer is, students, x raised to 4 minus 6x plus c. And c put in. This answer is a final answer of this question number, example number 4. Students, I one more time repeat, that type asking exam in the question set. Okay, students, and here I stop this part. Further explanation I explain to students in the next part. But I again request to you, students, necessarily write down formula list at least 5 times daily. Yes, students. Bye bye.